Right, so welcome everyone to July Love Night. So welcome Keith up to the floor now to give us a bit of information about bird flu.
Good evening, everybody. So this is the bird of the evening today is a virus. I thought I'd talk to you about some background stuff and just give you the basics of the virology of this organism, this disease, if you like. Just so that when you encounter weird stuff on social media or the news, you can sort of go back to basics and say, give it the pub test and see if it makes sense. So a few basic things about viruses first. First thing to appreciate is they're really, really small. You can't see them with an ordinary microscope, you do with an electron microscope. And their size is of the order of nanometers, billionths of a meter. So when you think about trying to keep something of that size out of Australia, you sort of start to realise the problems that we encounter. So this virus here is about 100 by 10 to the minus 9 meters. The other thing to appreciate is that viruses can't exist on their own. They're not like bacteria or animals or whatever. They can't live on their own. They must live within, they must multiply within a cell, within another cell. So if you look at this light blue patch as being, say, a cell in your respiratory tract, the only way the viruses, these particles here, can multiply is if they hijack that cell and use the machinery of that cell to multiply up and then produce hundreds, thousands, who knows how many more viral particles from just the one. So they must live within the cell, in intracellular organisms. This is a sort of schematic of the influenza virus. Influenza A, we're only talking about influenza A tonight. And there's a couple of important things to appreciate about this. As I showed you in that previous slide, the virus particle's got to attach before it can get inside the cell. The attachment sites are these two spikes here, hemagglutinin and neuraminidase. And you'll see how they play along shortly. The other key thing to appreciate is the influenza virus. All viruses have got to have either RNA or DNA. The influenza virus has got RNA, which is actually relevant to the situation. And while you're thinking about that, the COVID virus is an RNA virus. I'll explain more in a second. So the hemagglutinin and the neuraminidase, they're the attachment molecules that are required to start the whole process of replication. This is where you get the H and the N, so H5N1. So the H is hemagglutinin, the N is neuraminidase. They're just sort of arbitrary classification, if you like, but once they've sort of got into science, then you can sort of follow the logic of that classification, and more about that shortly. So if you're trying to stop a virus from getting into the cell and start infecting people or birds or whatever, you really want to stop it at the attachment site. So the vaccine, these two antigens here become the vaccine targets that you produce. You've heard of the spike protein and for COVID and how you're trying to produce a vaccine against the spike protein. And I think I don't want spikes in my body. Well, you see what they are. They're the attachment antigens. And if you stop the virus from attaching, then it's not going to get into the cell at all. And ditto with antiviral agents, which we won't talk much about after this. But if you're trying to help somebody who's sick, antiviral agents are supposed to work before the virus gets in. And as I said, this is how you characterise the influenza virus. And I've got a table up shortly which will show you, but they come in all sorts of numbers based on the H's and the E's, H5N1, H2N3. And in our case, we're talking about H5N1, and I'll explain where that came from. And at the moment, we're actually going site a subspecies of birds, if you like, the subspecies of this H5N1, which we're interested in is clade 2.3.4.4b. And that's what the laboratories are trying to identify at the moment. When you send the sample off, it's going to end up, at the moment, looks like it's going to end up in Geelong, where they're one of the few places, possibly the only place, I don't know for sure, one of the few places that can get down to that clade level and say we're talking about the same virus that's been going through other parts of the world and the Antarctic. So a couple of other things, interesting things about viruses. Because this is an RNA virus, when it gets into the cell and replicates, this process is quite complex, more so than the DNA viruses like measles or rubella. As a result, the virus is prone to mutate slightly. And this is the reason why you need a vaccine every year for the influenza virus. It changes just slightly all the time. And in fact, what's coming in is slightly different to what's going out. Only minor, this is antigenic drift, and it's very common. But what happens every now and again, you get a major change, a reassortment of the RNA, such that you're getting an antigenic shift, which leads to a pandemic, or in the case of birds, a panzootic. And you need three elements. You've got birds, these are chooks in here, humans and pigs. And the viruses exist in these, and they sort of get swapped around and mutated significantly, and that's where you get these, basically a new virus, if you like, which becomes the problem. All influenza starts off as bird flu, just out of interest. So this is a table I've cobbled together, and it's not perfect, but it gives you a general idea of what's going on. So seasonal flu, which we're sort of heading into the season, flu season at the moment, is an annual event, affects humans mainly. It's infectious, it can be quite nasty. It does kill maybe each year 1,000 or so people, and you need a tailored vaccine for it. That's the antigenic drift. Thank you. The pandemic flu, flu A, always flu A, like Spanish flu, is when you get an antigenic shift. Humans, highly infectious because none of us have seen this virus before, so it becomes more effective at being infectious. High mortality, rapid need for a vaccine. The vaccine you take months, say 4 to 6 months. Now we start getting to bird flu. The bird flus that we've seen, particularly in Victoria, but we get all over the place. We've had them in our area, Tamworth and what have you, the H7s. Wild birds have a sort of a background rate of around about 2%. That's from studies that have been done in Australia, but it doesn't seem to affect them too much. In poultry, highly transmissible, and I say it's got a high mortality rate because the method of treatment is cold, so you've got 100% mortality rate. Rarely in humans, I'll come back to that in a second. Now, the one that we're interested in at the moment, the H5N1, is a panzootic event. Birds, over 400 species have been affected by this, and more than 56 species of mammals. Highly infectious, high mortality rates, rarely in humans, and this is the claim that we're interested in. I say these two rarely in humans. Yes, there have been cases of H7 and H5N1 infection in humans. It's uncommon. It mainly occurs where you've got the birds in very close proximity. This has happened a lot in Asia, where you've got people living with the birds. They literally, poor household community, they might have the pigs downstairs or in the next room, and they've got the chooks running around. So you've got those possibilities of the three sources from coming together and then causing a problem. But rarely in humans. Here, it's usually just a mild disease. So that's the H7, if it occurs at all. Here, now I checked with the other AI, artificial intelligence, and it tells me that about 1,000 people have been infected by the H5N1, and there was about a 40 to 50% mortality rate. So that's a high mortality rate, but it's not, humans really get it. In the USA, where they've had the problem with the dairy cattle, 71 people got it, all working with the dairy cattle, and one person died about 1 or 2 events in the city. So, and the other thing important is that I've only heard of one case of human to human spread. So once it gets, once you pick up this, it'd be very unlucky to get hold of it. Very hard to spread to other persons. So influenza symptoms all day: runny nose, sore throat, headaches, fatigue, migraines. In birds, they may appear weak, unresponsive, display signs such as seizures, incoordination, breathing difficulties, sudden death. So I got this from Wildlife Health Australia, so this is what they're proposing, which they're saying. Overseas affected wild birds include waterfowl, ducks, wading birds, seabirds, and scavenging birds, including eagles. We'll come to that later. And in the conversation piece, which I saw the other day, now you will see these two people, myself, Class, and Michelle, really, their names come up regularly. In fact, Michelle's in the video link tomorrow, and they seem to have done a lot of the work. So I think they're getting pretty good information. Biggest risk is that infected or sick birds are eaten by scavengers, and birds and mammals, which could transmit the virus to ducks. Once in ducks, the spread of the virus increases dramatically, typically through feces, especially in the water. Importantly, ducks have very limited signs of disease when infected and appear to be able to continue to migrate. Some birds, if they're sick and they're migrating, you think that they will be affected to the stage where they might die during transit. Doesn't appear so with us. Continued surveillance and testing is critical, and for farmers with chickens and the like. We'll come back to that in a minute. How's it spread? Through direct contact, saliva, nasal secretions, droppings, indirect through contaminated dust surfaces, water, equipment. Person-to-person transmission, very rare. Risk of catching bird flu from eating poultry products, extremely low. Who's at risk of bird flu? Workers in commercial poultry farms, and anyone who's handling sick or dead birds. And I sort of keep in mind that we have wildlife carers in our group and bird banders. They seem to be talking to Rob, and he said they're well on top of that. Anyone who spends extended time caring your birds and whatever, they're increased risk. So how to detect H5N1? Cultural and electron microscopy, yes, that's the research tool, so forget that. The PCR, which is just amplification of a nucleic material, which everybody said with PCR COVID, well, it's just a technique, so you can do the same for an H5N1, and then you need to go further than that, genomic sequencing, to identify it to this level. Now, at the moment, I'm only seeing that the tests have been done in Geelong, at the Australian Animal Health Authority. I noticed that some of them sent off on Friday this morning still hadn't been identified fully as this clade here. So appreciate that you've got a delay in transport and you're going to get testing build up too, which is going to make it slow. So I would say several days turnaround time. Possibly rapid antigen test will come into being, and I've got a picture of one of them being used in the Antarctic. This here serology might be interesting in research because if you take the blood of the birds, you can see if they developed antibodies to it, so you can see retrospectively if the birds have been contacted. Okay, origins. This is a favoured suggested origin, which is this bar-headed geese flying from sort of Siberia and west, comes through Qinghai Lake in China and picks up some infection from the poultry manure that's used for the fish industry, the agriculture industry. That's a suggestive, I can't say that's for sure. But the H5N1 was first identified 30 years ago, and this clade that we're interested in at the moment about 6 years ago. So what? So this is the clade that we're now interested in. It seems to have started out in the east and then crossed into the west, and we were watching this happening all the time in countries like in Europe, in Asia, all the way across the northern hemisphere. But now this is starting to come down. This is the outbreaks that were occurring in the dairy industry, and it's come down into South America and then it's hopped across into the Antarctic. Now, interestingly, it hasn't come this way to Australia, which is sort of the shorter route. And there's a suggestion that the Wallace line, the ducks don't like crossing the Wallace line. Ducks and geese and swans tend to migrate this way or migrate this way. And even the seabirds haven't watered down from in this more direct route. But now we've seen the virus in the Antarctic, and you'll recognise some of its places, Kerguelen Island, Crozet Islands, and then more recently into Australian territory, which is Herd Island. So you can see it's sort of become a more illogical way, if you like, a roundabout way to come to Australia. And you will have all heard of the deaths, multi-species deaths, elephant seals, Peruvian pelicans, massive numbers and huge proportions of deaths. And then Herd Island, 75% of elephant seal pups were killed there. So that we're less than 100. I picked this up just in the last couple of days. So these are tracking devices on two species, brown skewers. This is Australia down here, and you see it weaves its way around Antarctica, but you can see these birds have been travelling. I guess these are just healthy birds, part of some sort of research study. You can see that they've landed in the south of Australia along the Great Australian Bight, which is exactly where we've seen these first cases. And you can see down the bottom of Victoria. And this one here the northern giant petrel. Ditto, it's landed here in Australia and further up into New South Wales.
Okay. Those birds wouldn't have known land before.
They wouldn't have landed.
No, they are purely pelagic. So the tracking data is at sea. The only reason we're seeing birds in shore was about every city.
If they are sick or injured, then, but that's how that's.
All the time, because so with this recent weather system we've had, we've got seabirds from the shore, but they might have nothing to do with the virus. But I'm just pointing out that those birds there don't ever come to land, have some other purposes. They're purely pelagic.
Unless there's some reason for them to watch the shore.
Yeah, they don't choose to.
No, that's not.
I mean, I was just pointing out, she said it's come to land here.
Well, they have lived there. I mean, seabirds have they? I guess what I'm saying is that the tracking shows that they end up in our part of the world, and if they've some sort of years ago, you can see the logic behind them ending up exactly where they've been found.
Yeah, I've always done that.
And this is also tracking terms showing that birds from Kerguelen Islands have ended up in exactly the same areas. A bit about surveillance. Surveillance has been conducted over the last few years, 2022, 2045, by Michelle, William, myself, Plus, and as we've already talked about, and they've been checking these areas here. But you'll see that there's a hell of a lot of Australia that isn't being surveyed. And here on this side here, talking about domestic animals and also the products. So poultry and dairy are the two products that have been affected so far. So we've got to look at a large proportion of Australia and the products and the poultry as part of their surveillance. So control, testing and surveillance, and this came from two so-called experts that I interviewed on the ABC just the other day. Australia's best bet at managing this is focusing heavily on testing and surveillance. Surveillance is very important with rapid laboratory diagnostic tests and identifying it down to genomic sequencing. So this is where the birds have been identified so far, and in fact, I checked this morning and several have been confirmed or strongly suspected. But I'll introduce you to the surveillance pyramid, which all epidemiologists sort of work with. This is what we hear about, 95 cases, the tip of the pyramid. This is what the actual number of cases are down the bottom. So we only actually hear about a small proportion of what is actually going on. And this is from Wildlife Health. Response activities following detections will depend on the specifics of the outbreak, enhanced biosecurity and hygiene measures. So this is what you can do if you identify this as a problem, cases that occur. Enhanced disease surveillance, carcass management, emergency conservation measures, restriction of visitors and activities. So there are a few things you can do if you're not rude with this regard. So this is what we have to do to report. If you see a sick or dead bird, don't touch them, avoid contact. Record what you see, report it to the emergency animal disease hotline. Sit there and get that done with your phone. And then when not to call is when you've got sort of issues that occur outside of what we consider to be an infected bird, a bird that's broken its wing or something. But I was talking to Mick earlier about what we're going to do when large numbers of dead birds occur on the shoreline. And that's something I think is going to take a pragmatic point of view on. You can't test every word, and the laboratory capacity will soon wilt under the pressure. So we're just going to have to be sensible when all these things happen. And I'll leave you with references and acknowledgement from a lot of these places. But Michelle really's got a really good website, and she keeps that up to date. So I think that's one to look at. This one down the bottom tells you how many cases have occurred. So that's useful. But the others will have their place. So that's where we're at. Background information. So when you see strange things being suggested on the news or on social media, you can sort of run it by some of this and think, does it make sense or not?